Hi, Aaron. So today we're talking about what gives AI its identity and why some models are better than at certain tasks than others.
Okay. And where do we want to start?
So, why do some AI models perform better at specific tasks like coding, writing, or image generation?
I think the main difference is how they've been trained and then the data that they have access to is what really makes the difference. So I think last time we talked around what a large language model is and how it learns. But it's important to make it consistent around the data that it brings in. So, for example, if you want something to be good at ITSM, then you just give it ITSM data and you don't confuse the model by bringing in data from outside. And therefore, terminology that can have multiple meanings globally becomes very specific to just service management. And therefore, that makes that model much better in that area. And then when you talk about things like image generation, so people would have heard of DALI, for example, its only reference point is image data and how that the language of that image. We spoke about how LLMs break things down into language, even if we wouldn't necessarily use that term. So it's taking lots of different image structures, manipulating across different words in order to have its ability to generate images. It uses a slightly different model as well. It uses something called diffusion. So what we mean by that is we take multiple possible outcomes and we merge them together in order to form, say, for example, an image. But the way that it puts that image together is subtly different to the way that we would write text. And therefore, that makes that model much more efficient and effective at image generation than a standard LLM. There are some public LLMs that try to do everything. So, ChatGPT is a good example, or if you're using Bing or Gemini, they're trying to be everything to everyone because they are globally available for a search engine. So they will get most things right, but they won't be amazing at certain things. So, for example, if you were just to flow IT service management data through Gemini, you're probably not going to get a perfect service management response every single time. You're going to get an approximation, whereas a very specifically built model for service management is going to give you a much better answer and a much better understanding. But it all comes down to training, the data it's got access to, and the quality of that data as well is really key. So making sure that you're only giving access to the pertinent data for the role it's trying to perform. And then the final difference is the way the AI has been told to respond. And I think we're going to come on to prompt engineering, but you can also train the personality of the AI, and that varies the way it responds back when it's asked a question.
Okay. And we often hear that AI models don't work in isolation. Can you break down how they fit into a larger system?
Yeah, so each LLM, as we just sort of said, will have its own specialities, ideally, and also it would have been trained to respond in a slightly different way. But by linking them together, it can allow us to have a much better response rate and a much better accuracy rate. So typically, we've always spoke about, or you use one AI or you flow your answer for a particular AI. But in reality, if you can chain them together, so you may use Microsoft's LLM to go and get data from your Office 365 and to categorize that and classify that because it's very, very good at it. Okay. And then you might flow that through a chat AI that is maybe specifically designed to answer service management questions. And then it combines those two things together to give a really high quality response. So you can link them together. You don't have to be constrained by one AI across your business. You should use the right AI for the right task. And you need to have that governed. So there should be a central strategy within your organization for control of that. But don't be worried about having multiple AIs and taking the best of breed, because that's the whole point. And therefore that can allow them to be sort of chained together, and it's going to give you a much better answer and a much better a much higher quality of response.
Okay. And so you've mentioned prompt engineering a couple of times now.
Mm-hmm.
What does that actually mean?
Prompt engineering is basically training the AI to have a personality and to understand how it responds. And I know personality is a big word, right? Okay. It's not really a personality as necessarily we would say it, but it's giving it a way of acting. And there's two different types of prompt, basically. There's system prompts, which are the way the AI is sort of built to respond. So a good example of that is, let's say, for example, I was an actor and I did stage musicals. Okay, I'm going to have quite a creative response, and I'm going to be very animated, and I'm going to use certain language in a certain way. Whereas, let's say, for example, I was a doctor. You want that person to be very calm and very articulate in how they're responding. They're two different personas. So, system engineering or system prompt engineering is about training the AI of the type of response it needs to give. Okay, it's that type of actor that it's going to be. It's going to be that type of personality. And then user prompt engineering is then explaining to it the type of question it's going to get and how it's going to be asked that question. So the two combined. So you might ask an AI a certain question in a certain way. In case, okay, I understand how I'm being asked. And therefore, I also understand how I need to respond, because this is what I've been trained to respond in and how I'm going to respond backwards. And prompt engineering has changed massively. So it used to be quite a closed IT shop, and particularly now user prompt engineering, we're opening up to wider audience, so we can get a bigger demographic. So we can get people that come from a psychological background or psychology background involved. We can get people from different job functions involved. So the quality, therefore, of the response gets much better and much more specific to the area that's using it, because we can open that area of AI up. We talked earlier, one of the previous pods actually, about it being a black box. Well, actually, we're trying to remove those barriers by saying, no, anyone can do this training. Anyone can produce user prompts, and therefore we can make it much better at operating within a certain industry. And also we can bring in more nuance to the way it responds, and we can bring in training from different backgrounds and different areas, not just IT people that are training it to be quite logical and very closed in the way it responds, but bringing in different types of personality and different job roles. We can make AI so much better in the way that it responds. And in essence, that's what prompt engineering is.
And do you think AI can develop its own identity over time, or is it always predetermined by training and prompts?
Yeah, it may inhibit some areas of that, but it doesn't have self-awareness, okay? It doesn't have a consciousness. When it improves its answers, what it's doing is going back over layers of data to get back to a formulated response. So whilst it has a certain level of sort of emergent behavior, so when it's told it's wrong, it will go back and relearn and correct its answer. And it's got much better at learning on the fly than it ever was before. So it will learn much more quickly than it did. It will take in much more responses than it used to. But I still think it doesn't really operate like a human does. Okay, it needs to be taught, and it needs to know what the right answer is. And actually, we have to be quite careful about the way we do that training. Back to an earlier point around, if you feed it poor quality data, you're going to get a poor quality response. So you need to try to make it reason much more than it can at the moment. And it's still very difficult to teach an AI to do that level of filtering that we do as a human. As a human being, we have confidence that either allows us to say, that's definitely not right, or you keep telling me this, but I'm not listening to that because I understand the difference between that being a correct answer and that being a wrong answer, or it's just not the answer for me. And that's a very difficult human trait to break down and for an AI to interpret. So what it tends to do is it tends to look at positives and negative results that it's got, back to sort of that reinforcement learning that we covered in one of the earlier pods. But that's the way that it's sort of changing its behavior. And back to the user prompts, you feed it better quality data in terms of how you want it to respond, and it will pick that up and it will improve. But I still think that's quite different to possessing a consciousness or what we would refer to as an identity.
Okay. And how does AI's ability to interpret prompts help in ITSM automation?
I think the better it gets at interpreting something, the more multifaceted its responses can become. Very rarely in ITSM is the first question you answer going to get you to solve that person's problem. And in many cases, the end user isn't going to know the specifics of the issue anyway. And they're going to use language which we in the IT department might not think they're going to use to explain a situation. So, for example, quite often we'll know that they're in application A, but that user has accessed that application through Chrome. And they'll just say, I was using Chrome and I couldn't do this. It's like, were you using Chrome or were you using a particular web application within Chrome? There's nuance, but an end user might not explain that. And by teaching an AI how to work through the prompts, can it start it to get that information out of the end user, so therefore we can more accurately solve the problem. And also a good example of that is if you've got people that are outside of an office environment, so for example, field engineers or colleagues working within a retail environment, the way that they're going to have an issue or want you to try to solve an issue is going to be quite different, and the language is going to be different, and also the time they've got is going to be different. If you're in a customer service environment and all of a sudden your till isn't processing properly, or it's taking a long time to process a credit card, it's quite a stressful environment. You've got a person in front of you, you're trying to serve them, you might have angry customers, a queue might be building up. So the way that you're going to want to get IT support is going to be different to somebody who's maybe sat in an office. So you have to be able to allow that prompt to be more nuanced and the way the AI responds to understand the scenario that the person's in. And I think that's where we're moving now. We can use that in terms of providing such a better service, both in terms of customer relationship management, but also ITSM. And that's why building in these prompts and building in those different user journeys is becoming so much more important, because we can give a much better experience straight away through a chat without necessarily having to call. Because in some scenarios, chat's easier. You can be chatting to something on a pad while you're still talking to somebody. Whereas if you're on the phone, it's a very closed scenario. So in a customer service world, sometimes that can be a more open way of communicating what's happening whilst trying to solve the issue. And by having a much more intelligent chatbot, it's going to make that experience much better, both for the end customer, but also for the colleague that's been put in that stressful situation.
And what's the biggest risk in applying AI models to ITSM, and how can we mitigate it?
I think the biggest risk is still what we term as hallucinations, okay? It's a term that we use within the AI industry where AI gets it wrong, okay? So it either picks up on a pattern that doesn't really exist, hence why we call it an hallucination, or it's been fed data that's led it to an incorrect conclusion. That is still a risk. If you're rolling out AI to the point of which you are going to automatically solve issues, you have to be really confident that the action it's going to take is the right action. So for many organizations where you're bringing in AI automation, you might do it to a level that's below your most critical systems. So you might allow it to try to solve a problem, let's say on a system that's critical to your business, but you still need to solve the issue, okay? So you might let AI handle that end to end because the risk is lower. Where you've got a critical system, I think where it's being leveraged at the moment is maybe to collect those logs, maybe suggest a potential fix, maybe suggest a pattern that it suspects is the issue, but maybe not let it press the button. Maybe let it go to an experienced engineer or a developer, but provide them all the information so they can still solve that problem more quickly, but you're letting them press the button because they've got years of experience, and you can rule out some of that activity where those hallucinations have occurred and a pattern has formed for whatever reason within the data, and it's flowed down that pattern, but it's not the right answer. And then you go back, you do a level of learning. This is where that closed loop analysis that we've always done in IT, where something happens, you find out why it's happened, you then make sure it doesn't happen again, and you update your documentation. That does not go away in AI. Okay, if it's got it wrong, tell it why it's got it wrong, correct it. So next time it gets it right. And it's the same mechanism. And we need to be focused on that as well to make it much more relevant not just for ITSM, but AI generally, but particularly within the service management world, where the consequence of running the wrong automation could be quite high. If it suddenly restarts your most critical system when it knows there's no failover, that's going to cause you a really business critical issue. So you need to be confident, but unless you tell it why it was wrong, it's never going to learn. So you've got to bring that into your processes for rolling AI out.
Okay. And where do you think models are going now? For example, we hear a lot about agentic AI.
Yeah, agentic AI is in essence a term for allowing AI to perform multiple tasks or related tasks. So based on the output of task one, it might vary what it does in task two. And in essence, that's what agentic AI means. So going back to my sort of my example of a store, or let's take it maybe outside of the core IT experience. I might have a chiller, so that's going to keep my pastries in my store at the right temperature. So whether that's keeping them at a certain warmth or whether that's keeping them at a certain cooling area, it's doing that job, and it's going to be monitored. And when that temperature changes within those boundaries, something's going to happen, and it's a technical IT issue. It's going to either reduce the temperature or it's going to increase the temperature. And there's massive automation now across all of these types of devices. Let's say, for example, the control mechanism of that and the variables that are happening within that. That's a use case where agentic AI could be making several different decisions to optimize the use of that fridge. And that might be for several different reasons. Maybe that's from an environmental reason. You don't want to overuse materials because they have a cost. They're worse for the environment. So we're going to look at modeling different changes in behavior or different patterns in behavior to sort of take that away. And therefore, we're going to make different decisions. Or, for example, we look at a pattern. So we say, well, actually, rather than going in to go and get our pastries ad hoc when we've got customer demand and we've run out, actually, if we had something that said, well, actually, once you take that pastry out, it's completely fine on the shelf for an hour, and we've done some analysis and that pattern retrieves, we just go in once. We don't keep going in, therefore the door's not open so much, therefore you don't need so much energy in order to keep that at the temperature you assume. Those type of decisions, and then the actions and consequences of those types of decisions are where AI can really help, to analyze those statistics, but then also those little those little tiny decisions that machine is making to keep something at the same temperature, we can be much more efficient by leveraging AI to do so.